Okay, students, now comes question number 16. Dear students, don't forget to subscribe to this channel because it's a supportive channel, in fact. So, coming to question number 16, says if x squared y plus xy squared is equal to 2x cubed, then you are asked to find the first derivative as well as the second one, okay? So how is this done? You need to recall, dear students, the implicit differentiation, right? So using that, we can determine the answers for these two. So what you need to do is you have to introduce d by dx both sides, right? You have to introduce d by dx for the left expression and d by dx for the right one. So as you are applying d by dx for the left expression, look, you need to undergo product rule for the first one. It will be 2x times y, right? Plus x squared will be taken as it is, and when you derive y with respect to x, will be dy over dx, right? So using implicit differentiation, we can obtain this. Look, this is like the derivative of x squared is 2x. It was actually dx over dx, which actually is 1 times y, plus now it's y, it is what y's turn to be derivated. Take x squared as it is, and when you take the derivative of y with respect to x, you are having dy over dx. Then plus comes, this plus is directly taken from this one. Now let's derive again this expression. Again, product rule needs to be used. So the derivative of x is 1, so you have 1 times y squared, as you see, plus. Now when you derive this y squared with respect to x, 2 comes down, then 2x times y, dy over dx follows. And this is going to be equal with derivative of this one, which actually is 3 times 2, 6x squared. Now once we obtain this, let's collect dy over dx here. We are having x squared and 2xy. Now let's take this terms 2xy and y squared to the right, and then we do have dy over dx is going to be equivalent to y prime. It's y prime. This is going to be equivalent to 6x squared. Move this 2xy to the right minus 2xy. Move y squared to the right again minus y squared divided by x squared plus 2xy. You see, you're having now y prime to be like this. So your first derivative with respect to x is obtained as you see. And sometimes you may be asked to determine the slope of a tangent line to this function at a certain point. In that case, you see the values, the coordinates of the point must be substituted here to determine the slope of the tangent line at that particular point. That's all about A. And when you come to B, students, in the case of B, you are asked to find the second derivative. So as you know, the second derivative is obtained as d by dx of the first one. So here the first one requires quotient rule because it is a ratio expression. So we need to derive the numerator, and we can have this one. Look, as you are deriving 6x squared, it will be 12x. And minus is taken into account. Now consider 2xy as a single entity. So as you are deriving this with respect to x, I'm now considering 2x as a single one. 2x derivative makes 2 with respect to what, student? 2 with respect to x, and then y comes here to y plus. And as you are deriving this one with respect to x, it will be 2x y prime. It will be 2x y prime. Minus derivating this again to comes down to y prime, and then using quotient rule you will consider or take this one as it is. Look, x squared plus 2xy is taken. Then from quotient rule minus is taken into account in between, and then you will consider or take the numerator as it is. Look, it is taken here, 6x squared minus 2xy minus y squared. Now it's this expression turned to be what? Derivative with respect to x. So this is 2x, as you see it's written, and then you need to undergo product rule for this. 2y with respect to x, 2y can come plus the derivative of this one is 1 times 2x is 2x, dy over dx, which actually is 2xy prime. Then this denominator must be squared, so it's squared here. So in order to know what y second prime is, dear student, we knew what y prime is because it's already obtained here. So in place of this y prime, you see, students, in place of this y prime, where else can we obtain? Here it is, y prime. You can directly substitute this expression. In fact, it will be a certain complicated expression, but if you are interested, you can simplify it. But I'm now going to leave this for you. But it is in this way that you can find, okay, y second derivative, okay? That is the idea. Now what comes next from this is question number 17, and in question number 17 you are given a function and you are supposed to obtain the equation of a tangent as well as a normal line here. So simple, at a certain point 0, 1. So I'm going to show you that. So the solution goes like this. First, you have to determine the slope of the tangent line. It's called that to be m, guys. So the slope of the tangent line at this point is nothing, but it is f derivative at what? At the x component, that means at 0. So f derivative at 0 must be calculated. This represents the slope of the tangent line for this function at this point, okay? So we need to determine the derivative of this function first, and that is nothing but it is 3x squared, as you see. The derivative of this is going to be 3x squared, so the slope of the tangent line at any x can be determined as 3x squared, but now specifically at 0, the slope is obtained to be 0 squared, which is 0. So if the slope is 0, clearly we know that it is a horizontal line. So y is equal to a certain fixed line is going to come. As you know, this is the equation of the line. So m is 0. So the line must pass through the point 0, 1. It has been given here. So when x is 0, y has to be 1, right? So when y is 1, look, x is 0. So when x is 0 and m is also 0, so the whole goes 0, so b turns to be 1, so y is equal to 1 is going to be the tangent line. Y equals 1 is, students, a horizontal line. So what do you expect the normal line for this tangent line? The normal line for this particular horizontal tangent line is going to be a vertical one, right? So x equals a certain, okay, a certain value is expected, right? Since, as it has been said, normal line is, you see, normal to a tangent line, and it has to be, you see, perpendicular to that, we can take x equal to, right? X equal to expression here, and that is 0, because the point 0, 1 is lying on the line. So x equals 0 is going to be the answer for this. Because x equals 0 is a perpendicular one, okay? X equals 0 is the y-axis, the vertical axis, perpendicular to y is equal to 1. Here, x equals 0 doesn't have a slope, because as we calculated before, the slope of this was obtained to be 0. Look, since the two are perpendicular to each other, the other one must be negative 1 over 0, but negative 1 over 0 is undefined. So the slope of a vertical line is undefined, right? So we need to consider x equals a certain line, but its x component, as you see here, is 0. So x equals 0, or the y-axis is the normal line, because the y-axis passes through the point 0, 1, and it's normal to the tangent line, right? So the normal line is x equals 0, or the y-axis, and the tangent line is y equals 1, right? So what comes next from this is question number 18. And here, in the case of this, you are given f of x squared minus 1, x from 1 to 2, then you are asked to find the minimum as well as the maximum value for this. So you need to recall, okay, finding extreme values for, you see, absolutes, global or all global functions, okay? How are you going to obtain absolute or global extreme values for a given function, because the given interval is a closed interval? So as you know, we have to first find, you see, the critical number for this, because we don't know where these absolute extreme values may occur when you are given a closed interval. So it might occur on the critical point or number. So we need to determine that critical number, and for that, f derivative at x must be 0, right, to find the critical number. So as you are derivating this, you obtain this to be 2x, and 2x must be 0. So from this, 0 is a critical number. Yeah, 0 is in the domain, but it is not within the interval, right? If it is not within the interval, we will reject that. So we simply consider 1 in 2. So when you substitute 1 there, it will be 0, right? It will be 0, because 1 squared minus 1 is 0. And as you are substituting 2, it will be 2 squared minus 1, 3. So clearly, the minimum value is 3, and the maximum value is what? The minimum value is 0, sorry. The maximum value is going to be what? 3. These are called global or absolute extreme values, okay? Now what comes next is question number 19. Here you are asked to find the integral of these two. So just apply what we discussed before. So using substitution technique, we can determine the integral of these expressions. So simple. So let you follow me. Now, students, for this particular case, what you need to do is let you use u to be radical x, okay? If you assign u to be radical x, the derivative of u will be 1 over 2 radical x dx. So, clearly, if you bring 2 here, 2 du can come, but 1 over radical x dx is available here. Look, 1 over radical x dx is available here. So, we can now totally write this expression of x in terms of u. Look, here it is. Cos is written as you see, but in place of radical x, u is used. And here, 1 over radical x dx is, like 1 over radical x dx is 2 times du, so 2 is written out, and the du follows. Then we know that integral of cos u is sine u, right? So this will be 2 times sine u plus any constant number, real number, okay? So finally, placing u's possible value, which is radical x here in place of u, we do have 2 times sine radical x plus c, so it is done. So when you come to b, you see, when you come to b, again here we need to use integration by substitution, and for that to come, let you use u to be cos x, because derivative is going to come upper here in the numerator one, okay? So let u is cos x, so its derivative is negative sine x dx, and sine x dx is labeled here. So you have to adjust in such a way to determine this integral, okay? So this is going to be like this. The integral of sine x over cos squared x dx is the question we are having at hand. So this is nothing but it is 1 over u squared, because this is already u, so 1 over u squared, but sine x dx is negative du, so negative can be taken out, then integral of du follows. And we know that this is the same as u to the power of minus 2 du, just making this u squared up, 1 over u squared is the same as u to the power of minus 2. So adding 1 here, and again taking minus 2 plus 1 minus 1, minus cancels minus, then 1 over u can come along, right? 1 over u plus a certain constant c, but we knew what u is, right? U is cos x, so a matter of putting that cos x here, and we know that this 1 over cos x basically is sec x, right? So c plus sec x can come. So it is this function that makes what this the derivative of what this one that makes what the integral here, okay? So what comes next is question number 20, and here you are also given what these two integrations. One is basically indefinite integral and the other one is definite, so we are going to answer this again. So the solution for the first one can be done by just simply having u to be sine hyperbolic of x squared, the exponent here, okay? So if you let u to be sine hyperbolic of x squared, the derivative of u respect to x is going to be like this. Look, you need to apply chain rule. First, you have to find the derivative of sine hyperbolic. It is cos hyperbolic of x squared. And as you are derivating the inner one, it will be 2x, right? So du will be this one times dx. Dx is forgotten here. Please add dx here, students. So du is this much times dx, right? So the integral, look, now dividing this by 2, we have x cos hyperbolic of x squared is equal to 1 over 2, what du, again dx is forgotten here, please try to add it. And from this can follow, x times cos hyperbolic of x squared is the power of sine hyperbolic x squared dx is, look, this is already u, e is a power of u, because it's already u, e is a power of u, and this is nothing but it is a 1 written here, 1 over 2 du, right? 1 over 2 du. So 1 over 2 is taken out as a common, as a constant now. So this integral is itself, so e is a power of u over 2 plus c can come, and we know what u is, sine hyperbolic of x squared, so directly put that there. E is a power of sine hyperbolic of x squared over 2 plus c is going to be the final solution. I hope it's getting simple, right? And what comes next is b. b is a definite integral again, but remember that the integral of 1 over 1 plus x squared is tan inverse x, students, because if you remember in our class, we have derived that the derivative of tan inverse x is 1 over 1 plus x squared, and integration is the reverse process of derivation. So the integral of 1 over 1 plus x squared clearly is tan inverse x. But evaluation must be done from 0 to 1, so from 0 to 1. So according to this fundamental theorem of calculus, we first put 1 here in x, and next 0 in place of x, taking minus into account, as you see. So this is going to be tan inverse of 1, pi over 4, and tan inverse of 0, 0. So pi over 4 minus 0 is going to come, and this final is pi over 4. So this integral is pi over 4.